Hello, welcome to Waka Waka Breaking It Down. This video is taking a look at angles larger than 90 degrees. So far, if you're watching this video, so far you've learned what SOHCAHTOA is and how to deal with trigonometry on a right triangle. But then we're asking ourselves, what happens if the angle in your triangle starts to get up to 90 and then past 90? Seems like a very weird thing. It's not as hard as it sounds. But it is weird. It's different. I mean, it's different what you're used to, right? So let's take a look up here. Let's look at this 150-degree angle in the top left-hand corner to begin with. Let me bring that down a little bit. Okay, so normally we have triangles like over, and we think of them like this, and we have an angle over here that's kind of, anywhere between 0 and 90. And that's kind of what we work with. What's the sine of 53 degrees and using that to find ratios of sides. Well, we're doing the same thing, but now we're allowing that angle, this angle right here, to kind of get larger than 90. Like we're letting this side length kind of rotate all the way over to somewhere else. And we're going to let it just keep rotating. Like maybe it goes here and maybe it goes here. And so far it's nothing new, still a right triangle. And then we're going to get all the way to 90, and that's going to be weird. And we'll talk about that at another time. And then we're going to let it just keep rotating. So what do we do when this gets past the 90-degree mark and gets over here somewhere, like you see in front of you with this 150-degree angle? Well, what we do is we just drop, like the triangle isn't over here anymore. That's kind of maybe the key. As soon as we hit the 90-degree angle, we're kind of flipping the triangle over to the other side. And instead of having a triangle here, we are going to have, like, really our triangle used to be like this, right? So it's still going to be kind of like a 90 degree, but now that 90 degree, this side length keeps moving over, and now it's over here now, right? Because our right triangle, whoops, let me draw a couple of them. We used to maybe have one like here, but then when we got over closer to 90, it was like that. And then when we come over to this side, it's kind of like this. So the height still kind of becomes the opposite side still. Like this was my opposite side in my triangle. So when I come over here, right, this side over here is still my opposite side. So the height of the triangle is still the opposite side. And then this is my base, is still my adjacent side of my angle that I'm talking about, right? So again, if I go back to the original kind of looking triangles, the base is the adjacent side to the angle we're looking at, and then the height is the opposite. So we're maintaining that. It's just that now, as soon as we get past 90, we're going to flip over, and the triangle now is kind of on the other side of the hypotenuse, right? This was always the hypotenuse that we were rotating around. So now my hypotenuse is over here, but we still have the height here, and we still have the base here. The base is still the adjacent, the height is still the opposite side. So the ratios of stuff, sine, cosine, tangent, still don't change. If I go to 150 degrees, what you have to do is imagine, well, even though this hypotenuse has rotated 150 degrees around a circle, the triangle is going to contain what we call a reference angle of 30 degrees. Why? Well, because there's 180 degrees in a straight line, right? We should have learned that from geometry. So 180 degrees, take away the 150, what's left over? Well, it's 130, or sorry, just 30, right? So those two together make 180. So my reference angle is 30 degrees. The angle that I see in this red triangle is 30 degrees. So when I say, oh, I want to do the sine of 150 degrees, what I'm really doing is asking myself, what's the sine of 30 degrees? Because it's the same triangle as a 30-degree angle over on this side. If this was 30 over here, the height of this, right, the opposite of this and this would be the same height. The hypotenuse of this and the hypotenuse of this are the same, no matter which, no matter where you're at there. If this is a 30-degree angle reference angle, or if you have a 30-degree angle to begin with. Same ratios. So that's why I can say now, like we know that sine of 30 is 1/2. We should have learned that by now. So I can also say the sine of 150 is 1/2 because its reference angle is 30 degrees. And we're just saying, oh, sine of 150, that's the same thing as sine of 30. Now there's one little thing we got to add on to that though. So if, well, here's the thing. This terminal side, by the way, we call like wherever that hypotenuse ended up at, that hypotenuse, we call that the terminal side of my angle. It's the, like it used to kind of start at 0 degrees and then it rotated around, and where it stopped, in other words, the name terminate means stop, right? So it terminates here. So it's the terminal side. It's the terminating side, terminal side, right? So that terminal side is the hypotenuse. But if that's in different places, we want our reader to know, and also it's going to make more sense when we put it all together. We have to keep track of, is this base a positive length or a negative length? And is this side a positive height or a negative height? And I'm kind of looking at this like it's a coordinate plane, right? Over here, this is positive. Whoops, let me redo this. Points over here are positive, positive, right? Points over here are negative, positive. It's the same thing with the sine and cosine because you're using side lengths. So when I look at something over here, the base is going to be considered a negative length because it's going to the left. And the height in this case is going to be positive because it's going up, right? We should be used to that idea. It's just transferring it over to trig now, right? So if I looked at, let me try, let's go down to this one. So I look at this one, right? This is a 45, 45, 90 triangle. I went 225 degrees total. So that took me 45 degrees past 180 to here. So my terminal side is in this third quadrant. The base of this is considered negative because we're going left. And the height of this is also considered negative because we're going down. So whenever I do a trig function for 225 degrees, like the sine ratio is going to be negative, the cosine ratio is going to be negative. The tangent's actually going to come up positive, right? Because you're going to take the negative divided by a negative when you do the tangent, and you're going to end up with a positive for tangent. So just keep in mind though, if you have a side like going in to the left, it's negative. If you have a side going down, that is also negative. Right, so when I look at this one, and by the way, this is just trying to get you to see different ways we can write angles. So this is showing negative 30 degrees instead of positive 30 degrees. So if I go in a counterclockwise direction, we consider that a positive angle. So in this case, it would be a positive 330 degrees, right? That's the same thing as going minus 30 degrees. Why? Well, because there's 360 degrees in a circle, right? We should all know that. 360 degrees in a circle. If this is a 30-degree reference angle, that means that this part of it was 330 degrees then, right? To make 360 total. All right, so what we call these angles, like a negative 30 and 330, we call those coterminal. Co meaning like coexist, or like co-ed. It's like both, right? So it's like co-ed basketball. Well, you have boys and girls on the same team, right? Same thing here. These are coterminal because they end up in the exact same spot. They're different angles, but they end up with the exact same terminal side. They end up in the same place, and they have the exact same reference angle, right? Okay, so those are coterminal angles, coterminal. But let's look at that whole positive negative thing I was saying. So because of this particular triangle, this is in the base of this is in the positive direction, and in the y direction it's a negative direction. And we don't really worry about the hypotenuse. The hypotenuse is always positive. So this is always going to be positive. So when I do a trig function like the sine of this 30 degrees, I mean, this is just 30 degrees in the triangle. But remember, I said we have to keep track of where we're at. So because we're over here in this fourth quadrant, I want my reader to know it's not really a 30-degree angle. It's more like a 330-degree angle. Then we're going to talk about the sine ratio of this being negative. Why? Because if you look in this triangle here, if I go across from 30, the opposite side is a negative number, which we can consider that to be like a negative x, right? If you remember, we use x's and stuff. And then the hypotenuse would then be 2x, but it would be positive. So we got negative x and 2x. So negative x divided by 2x, the x's will cancel, and you'll have negative 1 over 2, which is your negative 1/2. So it's, we know sine of 30 is a half. So you can just say it's a half, but you just have to add in that extra little piece of, is it really supposed to be a positive half or a negative half? Okay, so taking it one step further now. So since the sine ratio is negative, is the y value, sorry, since the sine ratio deals with the opposite side, that means it's really dealing with the height of the triangle this way, the vertical distance. So whenever you're below the x-axis, in other words, in the fourth quadrant, or if you're over here in the third quadrant, your y value, your sine ratio, is always going to be negative. If I'm in the second quadrant, right, or the first quadrant, of course, my sine ratio, which deals with the height, deals with this height, is going to be positive. And vice versa, if I do a cosine, that's dealing with the base. So if I'm to the right, if I'm to the right of this, so if I go to the right, it's going to always be positive. If I go to the left, it's going to be negative. So if I'm in this fourth quadrant, or if I'm in the first quadrant, I'm always going to have a cosine, a cosine that's positive. If, however, I go over to the second quadrant or the third quadrant, my cosine is always going to be negative, because this base that we're going to be using every single time is going to be negative. All right, now hopefully you can see that these triangles that I'm making, they're always like, wherever your coterminal side is, you just drop a line straight to the x-axis and make your 90-degree angle with the x-axis. So there's only 4 possibilities. It has to either look like one of these triangles in general, right? Now, of course, we can fine tune it to get it to look proper using the correct angles, right? But in general, these are the 4 different looking triangles that you're going to be working with, right? Either in the first, second, third, or fourth quadrant. All right, so that's coterminal angles. That's dealing with angles that are larger than 90 degrees. And what does all that mean? And how do we kind of deal with that? So the key, I think, is just find that reference angle after you've kind of made your triangle. So sorry, I should back up. Make your triangle. Once you get your triangle, think about the reference angle. And then from that reference angle, you can do all your trig functions, sine, cosine, tangent. And the last thing you just have to remember is to think about, is it supposed to be a negative or a positive? Depending on, did it go left and up, or did it go, left and down, or what? Okay, so you have to figure that out. Okay, so if we look at the worksheet that you have that goes along with this, the whole idea on this is that there's a spinner, and let's just say like you're taking the spinner from 0 and you're going to spin it, right? So maybe it goes this many degrees, or maybe it goes around and around and stops, or whatever. So you're going to spin the spinner, and there's different prizes on there, right? You can see lunch with the teachers, and you can do karate with me, or whatever. Okay, so let me blow this up a little bit. So the first one just says, in order to get lunch with one of the teachers, what do you have to spin to get that, right? So these are equally broken up. I know that there's 180 degrees in half the circle. So 1, 2, 3, 4, 5, 6, that's 30 degrees each section. Let's think about it. If this goes 30 degrees, 60 degrees, 90 degrees, that makes sense. 120, 150, and 180, right? So half the circle is 180. If I went all the way around, I'd have 360 degrees. Okay, so in order to get to lunch with teachers, I have to go 30, 60, 90, 120, 150 in order to get there. So I just have to be a little bit bigger than 150. So that would be our answer when we're talking about this. And we just need to know this terminology. Initial side of your triangle is where you started. That's always going to be at the 0 degree, always on the positive x-axis. The terminal side is where that hypotenuse goes. That's your hypotenuse, right? And then your angle, right? Your angle always goes kind of counterclockwise for a positive angle. Okay, so let's say they actually spun 150 degrees, or sorry, not 150, but 510 degrees. What does that look like? All right, so that means you went around. You can see here we went around a full circle to get 360, plus another 150 to make 510, right? 360 plus 150, that's 510. So you're going around more than once, right? And you end up kind of, well, exactly the same place as you did on the previous question. So these are what we call coterminal angles. You can see that over here, coterminal angles. Why? Because they ended up, or they terminated at the exact same spot. So this went 150, this went 510, but they ended up in the same place. So those are called coterminal. To get coterminal angles, you can always just add or subtract 360 from where you're at. Because if you think about it, no matter where you're at, if you just go around one more circle, you'll be right back at where you were. Or you can undo a circle and again, be right back where you started, right? So you can always add 360 or subtract 360 and just be right back where you started. So to get a coterminal angle, right? All right, so talking about lunch again. So yeah, we know that that's where you get lunch with a teacher. So, all right, so if you land on the starred line, so that's, if you look on these are the stars are here and over here. So that's going to be either 180 or 360 or 540 or 720 or, right? And you can keep going forever. All right. So if you land on the start line, you get an extra spin. So he spun 170. So how many degrees away from the extra spin was he? Well, we know the stars were on the ends. That's at 180. Who is this? Jacoby. They spun 170. So that's 10 degrees away from all the way like to half a circle, right? To getting all the way to the other side. So that's a 10-degree reference angle. That's how far away they were. So Ollie was 70 degrees away. How many degrees could he have spun? Oh, because he was 70 away from winning an extra spin. So that means that he was either 70 degrees away this direction, or this direction, or this direction, or this direction. This question is there just to get you to think about what a reference angle is. Reference angles are always based off of the x-axis, and that's why on the spinner we put these stars on the x-axis to kind of direct you to, no matter where you end up, you're going to go right to the x-axis to make your reference angle, no matter where you're at. So that's what's going on here, is trying to get you to see that, oh, this is the reference angle of 70. This is a reference angle of 70, 70, 70. All of those are considered 70-degree reference angles. It's always next to the x-axis. So you can see on the left here, it's talking about reference angles. Okay, so any of these angles would end up with the same reference angle of 70 degrees. Now the trig functions, even though they're going to have the same ratios, some of them would be positive, some of them would be negative, depending on where you're at. So you still have to think about the positive, negative, but because the reference angle is the same, all the ratios, like the value of the ratio, would be the same. All right, let's move on. Number 4. So this person spun clockwise instead of counterclockwise, and they spun 35 degrees. So we got a little picture over here on the right. So counterclockwise means you have a negative angle. So they actually spun negative 35 degrees. A coterminal angle to that would have been 325. So if I would have gone in a positive direction, that would have been 325 degrees in order to get to the same spot, right? So that's what we call coterminal. Okay. What's the smallest number of degrees? Yeah, so he would have had to go at least that much. I mean, I could always go around again, right? But that's not what we're talking about. We just want the first one, right? That's the first one. All right, so let's see here. This next one, the spinner point landed 2 centimeters right. Okay, so that's what you see here. And 3 centimeters up, so that's what you see here. Now they didn't draw it in, but this should be a right angle. And remember I said the triangles are always going to kind of look like this, where the right angle is down on the x-axis. So that's what we're trying to make right now. I know some people try to do this. They'll try to make their triangle this way, and they'll say this is the 3. That's a mistake. You don't want to do it that way. It's just not going to work. I mean, it'll be really confusing, and it's just not good. So please don't do that. Think about the hypotenuse has got to be like part of a spinner, kind of like what we're doing now, right? So it's got to be like angles going this way. So your hypotenuse always shoots out from the origin. Okay, so they want to find that angle. Once you get the picture drawn, it's not so hard because we know how to solve these now, right? So what ratio is this? Well, this is the opposite, right? And this is the adjacent. That has to be a tangent ratio. So you can see we wrote that equation here. Tangent is 3 over 2. To undo the tangent, we do the inverse tangent of both sides of the equation, right? Now, these don't cancel. I saw people saying the word cancel on their feedback quizzes and tests and stuff. It's not canceling. That's not what's happening. What's happening is they're undoing each other. Just like if I have x squared and then I take the square root of it. Actually, let me use an actual number, like 5. So if I do 5 squared and then I do the square root of it, 5 squared is 25. And then I'm undoing the 25 to come back with 5 that I started with. So it's not, technically it's not canceling anything. It's just going back to where you started. So it's undoing what you did. So I put a tangent on it. Now I'm going to undo the tangent, if that makes sense. Okay, so then you do this on your calculator, the tangent of 3 over 2. Make sure you're in degrees on your calculator, and you should get 56.31 degrees. All right, make sure you know how to use your calculator. And the important part of this question is setting the triangle up correctly. Now, these were both positive, but sometimes you'll get like a negative and a positive, right? Or you might get a negative, negative, and get your triangle that way. So be wary, be wary. Okay, I think most of this we've kind of covered the idea, coterminal angles, reference angles. So you should be able to work your way through the rest of these. I think, let's just take a look at this one because it has this negative on it. So I want to look at that. Well, so if you're given a point, right, just draw it out on a coordinate plane. So this is 6, negative 8. So that's 6 right in the x direction, negative x in the y. Notice we make that negative 8 because they told us it's negative. So we're going to go positive 6, negative 8 to get that point. And then I'm going to connect that to the origin for my hypotenuse. And then drop a line to the x-axis to get my right triangle. All right. So it's really important you know how to make these triangles properly. Right to the x-axis and hypotenuse goes to the origin. Don't lose the negative. The negative is important. Why? Because now when I do my trig ratios, so if I do the sine of this angle, I can use the reference angle. Even though we're talking about this angle, right? It's really the reference angle that we're kind of thinking about and looking at. So the sine of this big angle is the same as the reference one, but we have to include positive and negatives, okay? All right, so sine of that is opposite, which is the negative 8, divided by the hypotenuse, which is 10. How did I know it was 10? Well, that's just Pythagorean theorem, right? 6, 8, 10, that's a Pythagorean triple. Like 3, 4, 5, and multiples of that, 6, 8, 10. Those are all Pythagorean triples. Okay, so 6, 8, 10. So 8 over 10, or in other words, more specifically, negative 8 divided by 10 is the sine ratio. So we can simplify that down to negative 4/5, which you should do if you can. All right, let's look at the cosine. Cosine is the adjacent side to that angle. All right, again, we're looking at the reference angle. 6 is the adjacent, 10 is the hypotenuse. So that's the ratio we make for cosine, and you get 3/5. It's positive, though, because the 6 was positive. And then tangent, I'm going to take the opposite, negative 8, divided by the adjacent, which is the 6. One's negative, one's positive. So you can see that when you do your ratio, it comes out as negative as well for tangent. Okay, so two of these are negative, right? And then they do the extra work with inverse sine here to figure out what that angle would have to be. So 8 over, like they use negative 8 over 10 if you want to use sine. You didn't have to though. You could have done negative 8 over 6 and used the tangent ratio. It wouldn't really matter. You'd still end up with the same number. Now keep in mind, this is when you get your answer here, and it'll come out as 53, or it'll come out as negative 53 on your calculator, I believe. Maybe we should try that. So this is negative 8 over 10. Let's try it. So if I do negative 8 over 10, and I do the inverse sine of that, yeah, you see how this gives me a negative number for my angle? So it knows, the calculator knows that it's down here in this fourth quadrant down here, and that reference angle, or that angle that you're looking at, is a negative 53. It's down here. You can transfer that over then, right? And say, well, if I take 360 and take away that 53, take away that 53, then I'll end up with this actual positive angle, this big one over here, which ends up being 306. So that's a really good problem right there. It's setting it up and using inverse trig to find your angles that are in different places, right? That are not just in the first quadrant. Okay, that's a really good start to all the meat of our unit, right? So far, it's kind of been review of geometry, and this is the first lesson where it really starts to kind of become new, right? Everything's new. We're looking at angles bigger than 90 degrees, which we've never done before. So exciting. All right, it's going to just keep on going, until, well, it never stops in math, doesn't it? All right, good luck. Happy studying. Ask me questions. Come in for help.